Okay, so this is a review for test 3, and we just finished the first 7 problems together and are recording the rest of it. So actually we're on number 7 in test 3 review. All right, so in number 7, a poll of 280 randomly selected adults showed that 48% of them are allergic to cats. Use the 95% confidence level and sample data to find a confidence interval for estimating the population proportion P. All right, so for the confidence interval, I told you about the program on your calculator. We're going to hit stat, test, and then scroll all the way to the bottom to A, and on my calculator it's A, to the 1 proportion Z interval program. We need X here. Now they give you N, they give you P hat, but they don't give you X. All right, so to find X, we use the formula X equals P hat times N. That comes from the fact that P hat is equal to the proportion X over N. Okay, so if you know this formula, then you can see we could solve for X. X is equal to P hat times N. Okay, so P hat is 0.48, N is 280. We multiply and we get 134.4. But we need to round that because we're talking about people here, and rounded to the nearest whole number will be 134. So that is my X. Okay, so using the 1 proportion Z interval, we have X, which is 134. N is equal to 280. And the confidence level is equal to 95. Okay, so I'm going to start over with you. Stat, test, 1 proportion Z, and we have 134, 280, and 95. So my interval is 0.42 to 0.54. Rounded to the nearest 100. So the correct answer is D for number 7. All right, let me know if you have any questions. All right, we're going to go on to questions 8 through 13. And we're going to start with our hypothesis tests. A survey of 6,241 randomly selected households showed that 4,300 had computers. Use a 0.05 significance level to test the claim that fewer than 70% of households have computers. All right, so every time we're given a problem, you need to know what the claim is. All right, and it's usually the sentence that has the word claim in it. So I underlined that word. And there will be an inequality. So it's either less than, greater than, or equal, or not equal. So the claim is that fewer than 70%. So I'm going to rewrite it as, that's a proportion, right? 70%. So P is less than 0.70.
So it'll be C.
And so let's see. The correct answer, sorry, go ahead, Akachu. What were you saying?
D. Will the answer be D?
D. Yeah, it is. Well, is it D? No, because this is standard deviation, right? So just remember what your parameters are. Okay, I'll go ahead and put this in the on the side here in the margin. We have, well, I can't write out there, but okay, so P is proportion, right?
Mm-hmm.
So anytime you're given a percent, right? Or a proportion, we're going to use the parameter P, okay? And then mu is the mean or the average. And then the other parameter would be sigma, and that stands for the standard deviation, okay? So in this problem, the claim is about a proportion because they're giving us a percent. So it is P. Okay, so to set up the null, we always take the parameter P and set it equal to that number. So P is equal to 0.70. So that's the null. And the alternative hypothesis is P is less than 0.70. Okay. So that's the setup. Then we find the critical value. And we can look that up in the chart, or we can put it in our calculator. Okay. I'm going to do both just to make sure that we, to see that you understand how to do both. So we're going to look up the critical value for an area that is, let's see, it says a 0.05 significance level. And the fact that this is fewer or less than, this is going to be a left tail test. All right, so since we have this less than, it's going to be a left tail test. So I'm going to do a quick sketch here. My critical value will be at the edge of an area that is equal to 0.05 on the left side. All right, and that's alpha, that's my significance level. So we go to the Z table. And since this is a left tail test with an area of 0.05, our Z score is going to be negative. So we're going to go to the negative Z scores. And the area is 0.05. So the innards of this, and it's so common that it has an arrow. It's somewhere between this area of 0.0505 and this area of 0.0595. So we're looking for the Z score that's between these two. So we go over to the left, it's 1.6, and then up here, it's between the hundreds place of 0.04 and 0.05. So 1.645 would be the Z score. And it gives it to you because it's common. Okay, so that's how we look it up in the table. All right, remember it's negative 1.65. We can also look this up in our calculator. We go to second vars, inverse norm, and we put in the area 0.05 in the left tail. The mean is 0 because we're talking about a Z distribution. The standard deviation is 1. That's usually by default. Hit enter. And enter one more time, and we get negative 1.65. It's actually negative 1.645. Yeah, let me correct that. Okay. Yeah, I'm going to do a better job. Okay. And it looks like it's taken it to 3 decimal places to the right. Okay, so what is the correct answer here?
B.
Is B. Good job. Okay, then the sketch, it looks like we already did the sketch. It's a left tail test, so we know it's not A. So the question is whether it's B or C. And I'm sorry, I already did this problem for you, but so the rejection zone is the shaded region. So the graph that depicts the shaded region as a rejection zone is C. Okay, the rejection zone means this is where we reject the null and support the claim. And the area to the right is the fail to reject zone. All right, so determine the test type and calculate the test statistic. All right, since this is about a proportion, the test type is a 1 proportion z-test. Now we're going to use the calculator to find this program. Hit stat test and go down to 1 proportion z-test, which is number 5 on my calculator. P naught is the proportion in your claim. So let's go back up here. The claim is 70%, so this is 0.70. X is 4,300. N is 6,241. And this is a left-tailed or less than test. So we scroll over to less than, hit enter, and then we calculate and we get the data here. So the test statistic is negative 1.890 or 898, which rounds to negative 1.90. So the correct answer is A. And the p-value is 0.0289. And so the correct answer would be A or D. But how we know whether or not to reject the null, we're going to have to compare it with alpha. And the significance level they give you in the problem, they said is 0.05. So we're going to compare the p-value. If the p-value is less than alpha, we reject the null. If the p-value is greater than alpha, we fail to reject the null. Okay, so I'm looking at the numbers 0.0289 and 0.05. I go over 1 decimal over, they're both 0. Go 1 more over, 2 is smaller than 5. Therefore, the p-value is smaller and we reject the null. So the correct answer is D. So if you reject the null, support the claim, you have sufficient evidence to support the claim. All right, so looking at number 13, we're going to draw a conclusion. Since the p-value is less than 0.05, so we're looking at A or B here, we reject the null and support the claim. And then you just restate the claim that was in the problem, that fewer than 70% of households have a computer. All right, so any questions, everybody?
Yeah.
All right. Okay, so that was one set for a hypothesis test. We're going to go on to problems 14 through 19. Okay, and if you get a problem says majority, that is a proportion. A majority, it's greater than 50%, so the proportion is greater than 0.5. And a minority would be that the proportion is less than 0.5. Okay. All right, and questions 14 through 19. In a survey of 1,252 randomly selected workers, 53.75% had lied about being sick in order to use sick pay as opposed to using vacation time. Using the 0.05 level of significance level, test the claim that the majority, which is more than half, of workers have lied about being sick to save vacation days. All right. So we're gonna set up the null and the alternative based on what I just underlined, the claim in the sentence. All right, so we need, the claim is that the majority of workers have lied about being sick to save vacation days. All right, so majority, that's a proportion, and it's greater than 0.5. Okay, so that's the claim. So to set the null, we set P equals 0.5. And the alternative hypothesis, H1, is greater than 0.5. So the correct answer is C. Okay. Now we're going to look for the critical value. Since it's greater than 0.5, this is a right tail test. So draw a quick sketch. And the area in the right tail is the significance level of 0.05. Right, so that's my alpha. Alpha is 0.05. So we want to know what the z-score is for the area of 0.05 in the right tail. All right. So if you look it up in the table, you're going to have to use symmetry. All right. So if you just look up 0.05 in the table, you can do that, but it'll give you a negative z-score because it's always looking at the area to the left of the value. So using symmetry, we would have to make it positive, or you can use your calculator program. All right. So let's see, we're looking for the inverse norm. So second vars, inverse norm. Area is 0.05. And so the z-score is negative 1.645. And using symmetry, it's positive 1.645. Okay.
Miss Mulaney,
Yes,
on that, can't you just do the 1 minus 0.05 equals 0.95,
absolutely.
and then you look at your little chart and say 1.645 on that?
Absolutely.
Okay,
Absolutely. You can do that. One.
because that's what I formulated in my head.
I love how you did that. Yes. Yes, absolutely. So
work
that
smarter,
is
not harder.
0.95. Right. So so when you use the chart and this calculator, see, I have another calculator, which is the TI-84 plus CE, and it's so cool. Here, I'm going to introduce you to the plus CE in a minute, but oh, no, I don't want that one yet. Here, okay. Yes, okay. So what we want to do is subtract, we'll get the complement of the area in the right tail. So 1 minus 0.05 is 0.95. So the area to the left of this z-score is 0.95. And then using complements, we can find the value. I can find my calculator with my, there it is. So we're going to go to second vars, inverse norm, and the area is 0.95 to the left of the z-score. And now we'll get a positive z-score of 1.65. Okay. I just didn't want to introduce another thing, so I love the fact that you asked. Does anybody have the plus CE version of the calculator?
No.
I have this one, new this year.
I have that one. The
Oh, you do?
TI-84 plus SE.
Excellent. Okay, so this one, if you go to second vars, inverse norm, okay, and you put the area 0.05 and mu is 0, sigma is 1, because this is a z distribution. This is a right tail test. You choose the tail, paste, and it'll give you a positive z-score. Look at that.
1.6.
Yeah. So you don't have to do complements if you have a CE. Okay,
Okay. All right.
but I think most people have the plus. So that's why I use this. Okay,
Yeah. Okay.
all right. And so you can compensate by getting the complement or using symmetry to find the area in the left tail and then making it positive. All right. All right. So that is the critical value. The sketch is a right tail test, and this region is the rejection zone. So the correct answer is, let's see, 1.645 right here. It's B. And then we determine the test type. This is, we're talking about Z's, so that this is proportion, right? The claim is about a proportion. So we're going to do the one proportion Z test. All right, we go to stat test 5. The proportion is, the null is 0.5. That's the claim. X is what in this problem? Oh, we don't know what X is, do we? We're going to have to find it. We know N is 1252 and P hat is 53.75. So to find X, we need to take 53.75% of N. Okay. Oops, sorry about that. Everything's coming up. Okay. Right here. Copy. There we go. I just pasted that information because so I don't have to remember it. So we have N and we have P hat. So to find X, we take 53.75% or 0.5375 and take that of 1252 and put that in your calculator. And we get 672.95, which rounds to 673. Okay, now we go to the test, the one proportion Z test. 0.5. X is 673. N is 1252. And I think it said, what's my setup is greater than, because they said it was majority, right? And then calculate. So the Z, the test statistic is Z equals 2.657 or 2.66 rounded to the nearest 100. And so the correct answer is A, and the p-value is 0.0039. And so now we compare the p-value with the alpha. Since the p-value is smaller than alpha, we reject the null and support the claim. So D is the correct answer for number 18. Okay. Now we conclude in number 19. Since we reject the null and support the claim, the p-value is smaller or less than 0.05. So we reject the null and support the claim that more than half the workers have lied to save their vacation days. So the correct answer is B. Okay, so that covers problems using one proportion Z test over proportion. Now we're going to population means. So for questions 20 to 25, in previous testing, baseballs were dropped 50 feet onto a concrete surface and they bounced an average of 106.45 inches. In a test of a sample of 201 new balls, The bounce heights had a mean of 104.67 inches and a standard deviation of 10.79 inches. Use the 0.05 significance level to test the claim that the new balls have an average bounce height different from 106.45. Always underline the claim first. All right, the claim is, so I underlined it in pink here. The claim is that the balls have an average that is different than 106.45. So rewriting that using symbols, average is mu, different is not equal, 106.45. The null is mu equals 106.45. The alternative hypothesis is the claim. So the correct answer for number 20, informing the null and the alternative, is B. In number 21, what is the critical value that you'll use for the hypothesis test? So this is a claim that's not equal. So this is a two-tailed test. Draw a quick sketch. And the area in the tails is half the significance level because they're split up in the tails. So 0.05 is now split up as 0.025 in both tails. To find the critical value, we need to look up the t in our formula packet here, but we're going to need the degrees of freedom when we do that. And the degrees of freedom is n minus 1. So in this problem, n is what? 201. So the degrees of freedom is n minus 1, which is 200. So that's what we're going to need. And the area in one of the tails is 0.025. All right, so we're going to the t to find critical values. Degrees of freedom is 200, and the area is 0.025. All right. But, oh, by the way, it tells you, since we are doing a two-tailed test in this chart, we can just put the area in both tails as 0.05. Okay. It's under the same column as the area in one tail, if you notice. So since this is a two-tailed test, it's not even asking us to think about it. We just use the area of 0.05 in both tails. And using the degrees of freedom of 100, the t-score is 1.984, which rounds to 1.984 is why is that slightly off from what this is? 1.984 is 1.9. Okay. I don't know why mine is slightly off from what this is in the here. Let me make sure I got my n correct. Oh, it's 200, that's why. Okay, I'm sorry, n was 200, that's why I went to the wrong number. Okay, so the t is 1.972. Here we go. So the degrees, oh yeah, I did look up the wrong degree of freedom. So The T is 1.972, so the correct answer is C. The correct sketch would be a two-tailed sketch where the shaded region is the rejection zone where we reject the null. So the correct answer is B. And determine the test type. This is a t-test because we're talking about a population mean and t-scores. So we're looking for the t-test program in our calculator. We go to stat, test, and we scroll to number 2, which is t-test. And here we're going to choose between data and stats. Since they're giving us statistics, we choose stats. And they're going to ask you for mu naught, which is the claim, the mean. And that is 106.45. And the mean in the problem, this is the mean, the statistic, the sample mean. And the sample mean is 104.67. The sample standard deviation is 10.79. N is 201. And different, so this is not equal. And then calculate. And they give you the test statistic, which is negative 2.34. All right, so number 23, the correct answer is C. And 24, the p-value is 0.02033. And we compare the p-value with alpha, which is 0.05. Since the p-value is smaller, we reject the null. So the correct answer for 24 is A. So since the p-value is smaller than the significance level, we reject the null and support the claim that the balls have a bounce height that's significantly different from 106.45 inches. So the correct answer for 25 is A. All right, any questions, everybody?
No.
Okay. Questions 26 through 31. Quarters are currently minted with weights having a mean of 5.68 grams and a standard deviation of 0.067 grams. New equipment is being tested in an attempt to improve quality by reducing variation. A simple random sample of 41 quarters is obtained from those manufactured with the new equipment, and this sample has a standard deviation of 0.052 grams. Use a 0.05 significance level to test the claim that quarters manufactured with the new equipment have weights with a standard deviation less than 0.067 grams. Underline the claim in the problem. All right, so the claim is that the quarters with the new manufactured with the new equipment has weights that have a standard deviation less than 0.067. So the parameter we're using is sigma for standard deviation of a population. It's less than 0.067. So setting up our null, mu equals 0.067. And the claim, the alternative claim is mu is less than 0.067. So the correct answer for 26 is D. Okay. Now to find the critical value for a standard deviation. The critical value for a standard deviation and the test statistic will both be chi-squared. And let's see, we're going to need our degrees of freedom. Since we have a sample of 41 quarters, the degrees of freedom is 40. And the area in the left tail, because we have a significance level of 0.05, right? So the area is 0.05. And because it's less than, we knew this is a left tail test, okay? And the last chart is your chi-square distribution. The area, it tells you how to use the chart at the very top. It says the area to the right of the critical value, okay? So the area to the right of the critical value using complements is 1 minus 0.05, which is 0.95, okay? So the way we use this chart is you definitely have to get the area to the right of this value. And the degrees of freedom is 40. All right, so we're going to use the fourth row here because the area is 0.95 and scroll down to 40. And so the critical value is 26.509. So the correct answer is 20 for 27 is A. Okay. We got a sketch already. That's a left-tailed test. And the critical value is 26.509 to the left. So the correct answer for 28 is B. 29, calculate the test statistic. Now here, we do not have a formula for sigma, for standard deviation. We only have programs for proportion and mean, but when we're talking about a standard deviation, we have to use this formula. And this comes directly from the packet again to find the test statistic. So, all right, so we're at the top of the packet here. And we're going to go to the second page. And at the very top on the left for chapter 8 is test statistics. And they give you formula. Now we have programs for Z and T, but we do not have a program for chi-squared. So we need this formula here. Go ahead and write it down if you haven't already. Chi-squared equals n minus 1 in parentheses times the sample standard deviation squared divided by the population standard deviation squared. Okay, so I'm going to write it down again. Chi-squared equals parenthesis n minus 1 times s squared over sigma squared. The degrees of freedom, that's n minus 1, is 40. The sample standard deviation is up here. And the sample, they said it is 0.06, no, what is it in the sample? It's 0.052, right? That's the sample standard deviation is 0.052. And the and sigma is 0.067. That was from the claim. Okay. All right, so go ahead and put this in your calculator. 40 times 0.052 squared divided by 0.067 squared. Hit enter and we get 24.09. That is our test statistic. Now it's asking us if we're going to reject the null or not, and notice we're not using the p-value in this problem. We're actually using the test statistic to form a conclusion. So to use a test statistic, we have to compare it with the critical value that we got in number 27. So I just drew my sketch again. where it shows the shaded region bounded by the critical value of 26.509. And I have to figure out where to put this test statistic on this number line. It's 24.09. And that number is less than 26.509. So we have to put it to the left of that number. So since the test statistic is in the shaded region, it's in the rejection zone where we reject the null and support the claim. Okay. So the first several problems we did was forming a conclusion by comparing the p-value to the significance level in the problem. But here we're comparing the test statistic to the critical value. Okay. So because the test statistic is less than the critical value, the test statistic falls in the rejection region, so we will reject the null. And based on questions 26 through 30, does the new equipment appear to make quarters that have significantly less variation than the previous minted coins? All right, and so we can definitely support the claim. So we say yes, since we reject the null, we have sufficient evidence to support the alternate claim, H1, which says the new machine produces quarters with less variation than the previous minted coins. Okay. How are we doing so far, everybody?
Good. Good.
Good. Any questions? All right, so we've covered all of the three: proportion, mean, and standard deviation, right? And we'll do another problem here with chi-squared, and then we're going to do a 2 sample means. Okay. All right, so for questions 32 through 37, bottles of powdered vitamin C have a mean weight of 16 ounces with a standard deviation of 0.082 ounces. A new cheaper machine was installed and is tested to see if it produces bottles with the correct weight. A sample of 61 bottles was tested from the new machine, and the bottles were found to have a deviation of 0.091. Use a 0.05 significance level to test the claim that bottles produced by the new machine have a standard deviation higher than 0.082 grams. So the claim in this problem, underlined here, is that the new machine has a standard deviation, so that's sigma, higher, so that's greater than 0.082. Sigma is greater than 0.082. That's my claim. The null hypothesis is sigma equals 0.082, and the claim is, the alternative claim hypothesis is sigma is greater than 0.082. All right, so that's A. 32 is A. 33. Find the critical value. We'll go to our chart again for a degree of freedom of 60, and the area. Now remember how we use this table is we always look up the area to the right of the critical value. The last problem, we had to, it was a left tail test, so we had to find the complement of the area on the left side. But here we just take this significant level. Since we already know the area in the right tail, we use it. So go all the way to the bottom. And the area to the right is 0.05. So that's this second column in the second set. And I'm going to say 1, 2, 3, 4 columns over from the right. And I think it's 40, right? Degrees of freedom. Or is it 60? It's 60. Okay, so we're going to go down to 60. And so the degrees of the degree of freedom is 60 and the area to the right is 0.05. That gives us a chi-squared critical value of 79.082. And so the correct answer is B. Calculate the test statistic. We have to use the formula again, n minus 1 times s squared over sigma squared, where the S is the sample standard deviation, which is 0.082. And sigma, nope, that's the claim, right? Let's look at this. Here it is. It says a sample. They give you n. And it says the standard deviation of the sample is 0.091. There we go. And then, so S is 0.091 and sigma is 0.082. So we put this in our formula. We get 60 times 0.091 squared divided by 0.082 squared. And we get 73.89. And that's our test statistic. Now in the next one, we're going to have to form a conclusion. So we have to compare it with the critical value. And the critical value is 79.082. And the test statistic is smaller. So it's out here in the fail to reject zone. Based on answers to those questions, the test statistic is less than the critical value. Therefore, it does not fall in the rejection region. So we failed to reject the null. So C is the correct answer for 36. And 37, since we failed to reject the null, we cannot support the alternative claim. So D is the correct answer here. Quarters are currently, oh, and I think that was it of that section there, 31, 32 through 37. Okay, so that grouping is done. And this is one singleton of a problem. Quarters are currently minted with weights having a mean of 5.68 and a standard deviation of 0.067 grams. New equipment is being tested in an attempt to improve the quality by reducing variation. A hypothesis test has been conducted to test the claim that the new machines produce coins with less variation. The test statistic is found to be chi-squared equals 24.5. The critical value is chi-squared equals 29.8. What do you conclude? All right, so we need to draw a graph here and compare the critical value with the test statistic. Okay, and we also need to know what kind of test this is. All right, so I underline the claim that the new machines produce less variation. So this is a left-tailed test. So a quick sketch will help. Put the critical value bounding that region to the left there. They say the critical value is 29.8, so I'm going to just label that there. And the test statistic is smaller, so it's inside the rejection zone. So the test statistic falls in the rejection zone, and we can say the new machines produce coins with less variation. So C is the correct answer. All right, the last kind of test we did in section 9.3 was over a two-sampled means, where you get two samples, brand X, brand Y here. Two types of flares are tested for their burning times in minutes, and sample results are given below. Test the claim that brand X burning time is greater than brand Y. Then use a 0.05 significance level. Assume the two samples are independent and have been randomly selected. All right, so first we have to set up the null and alternative. The claim is the brand X has a mean that's greater than brand Y. We're going to call brand X the first group, brand Y is the second group. So mu1 greater than mu2. That's my claim. And notice that this is very different from, it's a little similar from the previous tests, but the way we set it up is with no number because we're actually comparing two groups. All right, it used to be that when you do a hypothesis test about a proportion or a mean or a standard deviation, we're actually using the parameter, which is one of the symbols, one of the symbols with a number. In this case, we're using a parameter and comparing two groups with no number. So that's how it's a little different now. But we set up the null the same. We set mu1 equal mu2. And the claim, the alternative claim, is mu1 greater than mu2. So the correct answer there is B. The test type is a two sample t-test because they're giving us data for two samples. All right, we do have a program for this in our calculator. We go to stat test and we go down to the two sample t-test. That's number 4 on my calculator. And they're giving us statistics. So we're going to choose stats. And we're going to put the mean, standard deviation, and n for the first group. And just be careful, this order is not the same as what you have in your list here. The mean of group 1 is 19.4. The standard deviation of group 1 is 1.4, and n is 35. And now group 2, the mean is 15.1. The standard deviation is 0.8 and n is 40. And the test is greater than just click no for pooled and then calculate. And the result is that you have a test statistic T is equal to 16.03. So the correct answer in 40 is B. And the p-value is 3.67 times e to the negative 22. That's standard, I'm sorry, that's scientific notation for 3.67 times 10 to the negative 22. That's moving the decimal to the left 22 times. So you're going to get a p-value that's pretty darn close to 0. And that's less than alpha, which is in this problem 0.05. So we know to reject the null. So the p-value is 0 where we reject the null. So the correct answer for 41 is D. And in 42, the conclusion is since the p-value is smaller or less than 0.05, we reject the null and support the claim. So D is the correct answer. And does brand X appear to have significantly higher burning time on average than brand Y? Since we accept the alternative hypothesis there, that mu1 is greater than mu2, we say yes. Since we support the alternative hypothesis, we can say brand X burns significantly longer on average than brand Y. So 43A. And now we're going to construct a 90% confidence interval for testing the claim with the mean burning time for brand X is greater than the mean burning time for brand Y. We do have a program for that. It's the 2SAMP T int. So we're going to stat test, and we're going to scroll down to 0, which is 2SAMP T interval. And we're going to put our statistics in there again. And if you notice, it is already imported statistics that you put into the 2SAMP T test. And you just want to make sure that these numbers are right. So just refer to the table. The first group has a mean of 19.4, standard deviation 1.4, n is 35. Check the second group numbers, and I'm looking at those. They seem to be correct. But when you get to the confidence level, you're going to need to refer to what they're asking. And so for this interval, they're asking you to construct a 90% confidence interval. So I'm going to change this to 90. No pool, calculate. And we have an interval from 3.85 to 4.75. And so the correct answer is C. So notice that both intervals, both the low number and the high number are both positive. So there's no way for 0 to be in there in the interval. Okay. That means that the difference between these two means is going to be a positive difference. That means mu1 is greater than mu2, right? So if we subtract these numbers and we get a positive number, we can definitely say that mu1 is greater than mu2. Okay, and we know this because 0 is not inside this interval. It can never be inside an interval where both numbers are positive. It can also, it can't even be in an interval where both the numbers are negative, but that's not this case, right? So does the confidence interval support the conclusion? We say yes, since the interval contains only positive values. mu1 minus mu2 is significant and positive, which indicates that mu1 is greater than mu2. And that supports our conclusion to support the alternative hypothesis. That was a handful. So tell me, do you have any questions?
When I calculated that, my calculator come up with 3 points. It come up with B
With B,
on number
3.7.
44.
Oh, for number 44? Okay.
Yes.
All right, let's see. Did you use these numbers up here in brand X and brand Y? Did you use your
All
mean?
my numbers match yours except for the actual answer, which is weird.
Well, I think I know, I might know what that is. So go back to stat test, go to your 2SAMP Z-end. And the one thing that you want to check for sure is that confidence level.
Is it 2SAMP Z or T?
Oops, I just did that wrong, didn't I? Yeah, right. It's T. 2SAMP T interval, because we're talking about a means. And yeah, I'm talking and I'm yes. So make sure that your numbers are correct. So 19.4 is the mean, 1.4 is standard deviation, 35, and then we go to 15.1, 0.8, and 40. And then make sure your confidence level is what they give you in the problem. And it's 90. What does yours say?
That's where I messed up. I put 95.
There you go.
Eat your
All
bread.
right, where is this one?
Eat your food.
What question are we on?
44.
40.
Oh,
Yeah, there we go. Yeah, for this one, it's a 90% confidence level. So yeah, that's where we want to change that. And then calculate.
Now I have the same thing as you.
There you go. Good job. Okay.
I had to make sure though.
No problem. Very good. All right. So now
I don't
we're-
have the handout with me. So I didn't see the confidence level on there.
Oh, it's not on yours?
I didn't, I printed it off, but my teenager watched my kids over the last week because I went to Florida and it's not here anymore. So
That's okay. No problem. There it is. So, okay. All right. And then I think we did 45. So we answered that. And we are on the next set of questions here. 46 through 52. Now, I did promise to answer questions if you wanted to go into the Math Lab review. It's 6:40, so would you guys like to continue or take a look at some of the questions in the review on the homework?
Question. I think we can finish.
Okay,
agree.
sounds good. You guys are on a roll, so I'm happy to continue. All right, so in number 46 through 52, two diets are compared by seeing if the average weight loss in pounds for the two diets is significantly different, and sample results are given below. Test the claim that the average weight loss for the two diets is different. Use a 0.05 significance level and assume the samples are independent and have been randomly selected. So the claim is the average is different. All right, and again, it's two samples. So you don't want any number here. Mu1 is not equal to mu2. That's what different is, right? So that's our claim. And the null is always the equal, right? Mu1 equals mu2. And so the correct answer for the null and alternative hypothesis would be A. The null is mu1 equals mu2, and H1 is mu1 is not equal to mu2. And 47. Determine the test type. Well, this is a two sample means. So we're going to use our program here, stat test, two samp t-test, hit enter, and we have our statistics. So now we're going to change the numbers. The sample mean is 5. Standard deviation is 1.3, N is 41. In diet 2, the mean is 4.6. Standard deviation is 1.6 and N is 45. It's not equal. And the test statistic is 1.277, which rounds to 1.28. 1.28. So the correct answer for 47 is D, and the p-value is 0.2051, which is, and then we have to compare that to alpha, which is 0.05. So the p-value is greater than alpha. Therefore, we failed to reject the null. And 49, the conclusion is since the p-value is greater than alpha, we fail to reject the null and cannot support the claim that the two diets result in significantly different weight losses on average. D, which is pretty typical of weight loss programs, it seems. Okay, so the correct answer is D. 50. Can we conclude that the two diets result in significantly average weight loss? And we say no, because we did not support the claim. So we can't make that conclusion. So 50B. And now we're going to do the confidence interval. All right, remember what program we use? We go to stat, test,
Test, second sem.
two SAMP, T interval, right? And then stats. And let's see, we've got to use the information in our table. It should have imported. If not, go ahead and make sure it's in there. Yes, what's the sea level? For number
95.
51? 95, yes. Don't forget to change the sea level. And the interval is negative 0.223 to 1.023. Okay, I want you to see something here. It goes from negative 0.223 to 1.023, right? So the fact that you have a negative number and a positive number, can 0 be between these two numbers?
Yes.
Yes. So that does not rule out the fact that the two means are equal. Okay. So since 0 is in there, then the difference is not significantly large, because that means it could be equal to 0. All right. And let's see, let's go back up to our claim. The claim was that the two means are different. And so because the difference is not significantly large, this supports the conclusion not to support H1, okay? We are not supporting the claim, okay? So just see that A and B both support the claim, okay? So you definitely want to pick C or D because they do not support the claim. All right. Okay. So this interval does support the conclusion of the test because 0 is possible, meaning that the difference is not very large. Okay. In questions 53 through 58, a computer company claims their batteries last on average longer than the national average of 16 hours. They base this on a sample of 101 computers that have an average battery life of 16.4 hours and a standard deviation of 3.1 hours. Use the 0.05 level significance to test claim. Form the null and alternative. So the claim, as underlined, is that batteries last on average longer than 16. So the average mu is greater than 16. That's my claim. The null is mu equals 16, and the alternative is mu greater than 16. So A is the correct answer for 53. The critical value, let's see, this is less than or greater than, says it's longer, right? So it's greater than 16. So this is a right tail test. And since we're talking about a mean, this is a t-test. So already you can cancel out B and C because those are both Z values. So to find the critical value, we look it up in our chart for a degree of freedom of 100 and 0.05 level of significance in the right tail. All right, so the area in one tail is 0.05. Degree of freedom is 100. So it's 1.66. It's right here. So T is 1.66, and this is a right tail test, and that's the rejection zone that's shaded. So the correct answer is A. 56, determine the test type and calculate the test statistic. So we have a computer program for that. We go to stat test, t-test, that's number 2. And we're going to input the mu naught. This is statistics that we have. Mu naught is the claim of 16. The mean of our sample is what? So the sample of 101 has an average of 16.4. So that's the mean of the sample, 16.4. The standard deviation is 3.1. N is 101. This is greater than, because he said it was longer, right? So greater than. The test statistic is 1.297, which rounds to 1.3. So the correct answer for 56 is C. And let's see. What is the p-value? It's 0.099 or 0.0988 rounded to 4 decimal places. Then we compare that to alpha, which is 0.05. The p-value is greater than alpha, so we fail to reject the null. So that answer is A. So the conclusion is, since the, let's see, what are they asking us? How are they wanting us to conclude? Okay, so they're comparing test statistics. So so we can do the conclusion in 2 ways. We can compare the test statistic to the critical value, or we can compare p-value with alpha, right? So this area right here is 0.05, right? That's the in the rejection zone, okay? The p-value is 0.09. It's bigger than that, and it corresponds to a test statistic of 1.3, which is smaller than 1.66. That's the critical value. So we can see that the area, and I'm really exaggerating here, it's not that far over, but the area, the p-value is bigger than alpha. And the p-value is bounded by the test statistic, which is outside this rejection zone. Okay. All right, since the test statistic is smaller than the critical value, it does not fall in the rejection tail. So we fail to reject the null, and we do not have evidence to support the claim. So we can't say the batteries take last longer on average. And you can also use a p-value method. They put this in parentheses, right? But we did, they were asking us specifically to use the traditional method here. All right. So the answer is A. Any questions?
No.
No.
All right. Let's see.
I leave.
Is 59 a singleton? I think so. They give you test statistic. Yeah, okay. A researcher wishes to determine whether people with high blood pressure can reduce their blood pressure by following a particular diet. Use the sample data at the right. He wants to test the claim that the group receiving treatment has lower blood pressure on average than the group not getting treatment. So the claim is mu1 less than mu2. He performs the test. His test statistic is t equals negative 2.36. And the p-value is 0.0096. Can he conclude that the treatment diet appears to be effective in lowering blood pressure. All right. So if we compare the p-value to 0.05, a significance level of 0.05, right? The p-value is indeed smaller than alpha. Therefore, we reject the null and support the claim. Okay, and that's C. 60, a psychologist claims more than 56% of the population suffers from professional problems due to extreme shyness. Assuming a hypothesis test of the claim has been conducted, and the conclusion is fail to reject the null, state the conclusion in non-technical terms. Okay, so failure to reject the null means that there is not sufficient evidence to support the claim that the true population is. All right, now C and D are very similar, but the last part is just restating what the claim is, that more than 56%, right, suffers. So greater than 56%. Okay, so that's just a restating of the claim. 61, a claim is made more than 70% of drivers wear their seatbelts. A hypothesis test has been conducted at the 0.05 level, and the decision is to reject the null. What can you conclude? If you reject the null, you support the claim, and there is enough evidence to support the claim that 70% of drivers wear their seatbelts. So B is correct. In 62, a claim is made that the average test score for a particular class is less than 75%, which is the national average. A hypothesis test is conducted at the 0.05 level. P-value is 0.036. What can you conclude? So we compare the p-value with 0.05, that's alpha. 0.036 is smaller than 0.05. So we reject the null and support the claim. And so the correct answer is A. All right, because we have to restate the claim that the average test score is below national average. Okay. All right, we're almost done, guys. So I think we're done. We have one or two pages here, just 2 pages left here, and they go quickly at the end. All right, 63. A psychologist claims that more than 56% of the population suffers from professional problems due to extreme shyness. A hypothesis test of the claim has been conducted. The test statistic is Z equals 1.97. If the critical value is Z equals 1.645, what can you conclude? So they're asking us to draw a conclusion by comparing the test statistic with the critical value. You really have to draw a quick sketch when you're doing the traditional method so that you could see it on a number line. The critical value, oh, and you also need the claim. And it says more than 56%. So this is a right-tailed test. The rejection zone is in the right tail, bounded by the critical value, which is 1.645. This number, the test statistic, 1.97, is greater than 1.645. So it's in the rejection zone. Therefore, we reject the null and support the claim. So the correct answer is B. 64, find X. In a survey of 428 people, 10.5% of them are left-handed. They're asking us to find X. So we take 10.5% of 428. So converting this to a decimal, we get 0.105. And guys, if you know, all you're doing is moving the decimal over to the left 2 places. All right, so 0.105 times 428. So X is equal to 44.94. And that rounds to 45. In number 65 through 68, we're going to fill in the blanks. When using the p-value, we always want our p-value to be less than the significance level to reject the null. And when you're using traditional method for a right-tailed test, the rejection region is formed to the right of the what? It's always bounded by the critical value. And number 67, when using the traditional method, we must determine whether or not our calculated test statistic falls in the rejection zone to determine if we'll reject the null. Okay, so using traditional method, we're always comparing the test statistic with the critical value. Number 68, whenever we fail to reject the null, we do not have sufficient evidence to support the claim. Okay, just remember, if we reject the null, we support the claim. If we fail to reject the null, we cannot support the claim and do not have sufficient evidence. Number 69, the symbol alpha denotes significance level. Number 70, sigma denotes standard deviation in the population, right? I kind of wrote down a little sketch here of symbols that you need to know. That's in one of your handouts for population parameters. You have proportion, mean, and standard deviation. And those symbols as statistics are p hat, x bar, and s. All right. So when you're forming a hypothesis test, you're going to be using the parameters here: proportion, mean, and standard deviation. Express the interval in the form p hat minus e less than p hat plus e. Remember when we did this interval, we're going to find the midpoint, which is another way to say average. So we're going to add the numbers and divide by 2. 0.123 plus 0.129, enter, divided by 2, enter, is equal to 0.126. So that's p hat. Oh, and I didn't even need to. I was just looking for E. I was just looking at the question here. It's 0.126 minus E, but knowing that I already have my lower bound and my upper bound here, you could just, let's see, like this, looking at A. Yeah, we can just put it into an inequality where you have 0.123 is less than P is less than 0.129. So there's really no work to be done here. And so the correct answer is D. If they asked us to put it in the form p hat plus or minus E, we would have had to do this. Find p hat first, which is the point estimate. That's the average of these two numbers. And then subtract from one of the endpoints to get E. Okay, I'll just go ahead and do it for measure. All right, so E is equal to 0.003. All right, so I'm just going to write this. We can write the interval in 3 different ways: as an inequality, as an interval, and as p hat plus or minus E. And so I just did that. That's actually 0.126 plus or minus 0.003. Okay, so there's several ways to write this interval here. Now, if you subtract 0.003 and just check this, you'll get 0.123. That's the left number. And when you add this, you get this right number. So, okay. Number 72. If we assume the interval in this question, number 71, is based on a 95% confidence level, interpret this interval. That's just restating this. How do we interpret it? So we are 95% confident that the true population proportion is between these two numbers. Okay, so that's C. 73. Oh, we're almost done here. We have 3 problems left. Okay, and oh, we're almost at the end of 2 hours, so this has been pretty good, guys. For number 73, in a test of a sample of 201 new balls, the bounce heights had a mean of 104.67 inches and a standard deviation of 10.79 inches. Use the 0.05 significance level to test the claim that the new balls have an average bounce height different from 106.45 inches. Which is the correct interpretation of 104.67? So it's such a good question because a lot of people actually get confused with what number to represent in our claim. Just know that, you know, in all these problems, I have always underlined the sentence with the word claim in it and the parameter. So the claim is the new balls have an average different from 106.45. So this 106.45 is indeed the claim number, right? That's, we're talking about average. So mu is equal to 106.45, okay? That is my claim. So the statistic here is the sample which has 201 new balls. Then this sample mean is 104.67. So that number is indeed a statistic because we're talking about the sample. Okay. Number 74, if 0.05 if alpha is 0.05 and you're given TI-84 displayed to the right, what can you conclude? So here the p-value is 0.138. We compare it to 0.05, it's bigger, therefore we fail to reject the null. And finally, 75, alpha is 0.05 and you're given TI-84 to the right, what can you conclude with a p-value of 2.165 e to the -8. Now this is another tricky problem where you have to interpret this number. That e is scientific notation, which is times 10 to the -8. So we are going to move this decimal to the left 8 times, which is pretty near 0, and that's certainly less than 0.05. So we reject the null. And we're done.